And today we're going to extend Gaussian elimination to Gaussian Jordan elimination. Another mathematician comes along, adds some stuff to it and says, well, why don't we just keep going with this idea until we get it into what's called reduced row echelon form, which basically makes the identity matrix on one side. And if you have the identity matrix on one side, well, then this would say 1x is whatever the first number is, 1y is whatever the second number is, 1z is whatever the third number is, and you know the exact solutions to everything. So Gaussian elimination just got you to a point where you could solve for one of the variables and then we worked backwards to find the other one. This one, once you have it, you know what x, y, and z are, or just x and y, right away. So what we need to do is we need to make zeros in the corners and ones in the diagonal. And there's going to be sort of an order that you do this. You're going to do Gaussian elimination first, which got us the zeros in the bottom corner. And I don't know if you remember that we got those two green zeros first. Then we got that 0 second. So if we're going to start with that in Gaussian Jordan elimination, we're going to continue and then get those zeros third, and finally that 0 fourth. So we're sort of going to do Gaussian elimination to get zeros in the bottom corner, and then do Gaussian elimination moving upwards to get zeros in the top corner. And then make sure that we have ones along the way. So again, sometimes we rewrite our rows. If we can start with a 1 in the top left-hand corner, that's often very helpful. So goal number 1 in green, we want to get this to be a 0. So what am I going to do? I'm going to take row 2 and change it to be, well, row 2 minus row 1. 1 minus 1 would be 0. So again, we always, if you do row 2 minus row 1, then you're going to be adding or subtracting the corresponding elements in the columns. So 1 minus 1 will be 0. Notice that my row 1 is not changing. So I still have 1, negative 2, and 10 there. But then when I do 1 minus 1, I get 0. When I do 4 minus negative 2, I get 6. And when I do 16 minus 10, I get 6. Now our next goal will be to get the other one in the top right-hand corner to be a 0. But before we do that, once you have that 0 in the bottom, you can make this number here a 1 by dividing by 6, which is the same as multiplying by 1/6. So we often say multiplying by 1/6 because in matrices, dividing doesn't really exist. So multiplying by 1/6, that will change that to a 1 and a 1. And we already know now that y is equal to 1. In fact, with Gaussian elimination, you would have been done. From here, you could plug things in, go back to your equations, and find x. But in Gaussian Jordan elimination, now we want to find and make this one a 0 as well. So we're going to change row 1. What can we do? We can take row 1 and add 2 row 2s. That would make what's in the purple a 0. Because negative 2 plus 2 times 1 will be 0. So now my row 2 is not changing. So that stays at 0, 1, and 1. Changing row 1. Notice that when I already have a 0 in this bottom left, when I do row 1 plus 2 times row 2's, it doesn't actually change. This top one will stay a 1. But now row 1, -2 plus 2 row 2's, that gives me 0. And row 1 plus 2 row 2's, that'll give me 12. So now I know that x is 12 and y is 1. So I have some for you to try. There are 3, the next 3 are all 2 by 2's. This is not your next one, is it? Oh yeah, it is. Actually, the next 5 are all 2 by 2's. And then, so I'll let you try those. First one, whoops. I took row 2 and minus row 1 to get that 0. I cut row 2 in half to get the 1's. Notice this 2 here I'm not worried about yet. I'm going to leave it there for a bit. Then I'm going to do row 1 plus row 2. And finally divide row 1 by a half. And there's many ways to do these. You don't have to, like, your choices sometimes can change some numbers, but it's not wrong. Okay, let's look at the next one. There you go. I will tell you right away that the numbers are nice. See how you did on this one. I took row 2 and subtracted 2 row 1's.
Yeah, that's all I remember.
Do you see that you could have done 2 row 1's and subtracted a row 2? If your numbers are different, that's not necessarily wrong. Don't necessarily erase it. Because you might have just, your instructions here, you might have told yourself to do a little bit different, and it would still get the 0, but maybe you got +9 and +9. Or something different. But if you got b is equal to 1, you're fine in the end. If not, maybe something did go wrong. Then I took row 1 and minused 4 row 2's to make this a 0. Now the third one you're going to try, you're going to need to rearrange that original equation to start with. So sometimes we have to do a little bit of setup. So I will show you this. This is me moving things over. See, I moved the 4x over, so I would get 4x minus 3y. I moved the 5y over. I made sure that my x's were my first column, y second column. And once again, there are nice answers for this one. All right, I'll show you what I did on this one. So first of all, I made this a 0, so I took -2 row 2's and added row 1. If I rewrote that, I'd probably write row 1 minus 2 row 2's, but it's the same thing. That gave me a 0 down here. One of the nice things you can do, if you get frustrated with these and you're working on one and you don't know if you made a mistake, okay, you can type the original matrix into your calculator, do the reduced row echelon form on your calculator, and it'll give you this. And you'll say, I know x is 5, and I know y is -1. So sometimes what I do is I'm like, okay, I just changed row 2, and something feels wrong. That can happen. You'll look at something and go, I feel like something went wrong. Okay? Well, I can do a little check at this red spot here. This is telling me -13 times, and y is apparently -1. Is that equal to 13? That's my question. If it is, I know that step is right. No matter what numbers are there. You might not have the same numbers as me, but you could do a check in your line, right? Because if you had -15 equals 15, it's still true. It would work if you plugged in -1. So there will be some times that you and a friend are doing something, you look at each other's results and the numbers are different. That doesn't necessarily mean one of you is wrong. Probably both of you are wrong. No, just kidding. But you can take the answer and plug it in. The only time you don't get that advantage is on the test if it's non-calculator. On the test, if it's calculator, you still have to show all your work, but at least you would know what you need to get as your answer as a check. So I divided by 13 to make this a 1. Then here I can see if I multiply this by 3 and add it to this one, I would get 0. So I take row 1 and change it to row 1 plus 3 row 2. Divide by 4 or multiply by 1/4. I'll leave this up for a bit, but you can start the next one. Okay, this one adds a little bit of trickiness because this 2 and the 3 kind of make things awkward, right? Because they're not multiples of each other. So one thing that I do then is I say, well, if I double this one, that would make a 6, right? And if I tripled this one, that would make it a 6. So 2 times R2 minus 3 times R1. And this is where mental math starts to cause you problems. Okay, my row 1 isn't changing, but you should get numbers that make this, when you divide it by 7, make your y value 4. If plugging in 4 for y in this next step doesn't create a right answer, then you know you've made a mental math mistake. And you see there's just lots of chances for mental math mistakes because it's doubling row 2, tripling row 3, keeping those numbers in your head, adding them up. Now it becomes easy to make that one a 0. I can just do row 1 minus row 2. And you'll start to develop like some strategies of what makes your life easier for positives and negatives. So here I did row 1 minus row 2 because then I'd have 2 minus 0 instead of row 2 minus row 1, which would give me 0 minus 2. Not a big deal, but that negative there, avoiding it, was nicer. And I can just divide by 2 or multiply by half and get our identity matrix. So this example introduced the first time that we had to multiply both rows by something. And you might remember doing that in the elimination technique, right? Where you multiply one row by something, another row by something else. So when you were stacking them, a variable would eliminate nicely. The same thing happens in Gaussian-Jordan elimination. All right, our last 2 by 2. Again, I don't like these fractions. We've got an extra plus 2 there. We have to do some preliminary work. So the first thing I did was get rid of the fractions. Can you see that if you multiplied everything by 18, 18 would get rid of the 6, 18 would get rid of the 9, 6 times 18 is 108. If I multiplied everything by 18, this side by 18, this side by 18 would distribute, right? So there'd be 18 there and there. These ones would reduce, right? These two would reduce and give us that 2. 18 divided by 6 would reduce and give us 3, and 3 times 5 would be 15. Same thing in the second one. Can you see that I multiplied everything by 12? Okay. And you can either multiply everything by 12 or another strategy like I multiplied everything by 18. Okay. another strategy here, and some people really like this, I actually really like this, is saying, okay, what would be the common denominator between 6 and 9? It would be 18. So does it make sense that I can multiply the top and bottom by 3 here? The top and bottom by 2 there. And the top and bottom by 18 there. Would that not give me a common denominator of 18 for all of them? Then if you have a common denominator of 18 for all of them, well, now if you multiply by 18, that would go away, that would go away, that would go away. And what am I left with? 3 times 5 is my 15. Just a 2 out in front, it's still just a 2 out in front. 16 times 18, 108. So I really like that as a strategy. So for example, in this next one, what's the common denominator between 3 and 4? Would be 12. So I would take this first one and multiply the top by 4 and the bottom by 4. The second one, the top by 3 and the bottom by 3. Top by 3 and bottom by 3. If I had a common denominator of 12 in each of those fractions, I could now multiply everything by 12, which would just get rid of those denominators. And I have 4 times 2x plus 1, 3 times the 5y, 7 times the 3. Rearrange this until I get my starting matrix. Ugh, how are those for numbers? Mental math nightmares. If I want to get this a 0, how am I going to work with 15 and 8 to make that a 0? Well, sometimes you might want to do something like this as a preliminary step. I'm going to take row 1 and multiply it by 8. I'm going to take row 2 and multiply it by 15. Mental math numbers are not very nice here at all. So this would be an example of one. If it came up, would probably say, show your work for Gaussian Jordan elimination, but I'll put this one on the calculator part of your test. So you're not allowed to just cheat and only write x is 4, y is 1. All my work is on a separate piece of paper, which I destroyed. Please give me 100%. Okay. But then multiplying by 8 and multiplying by 15 is fine. Okay. Then I can do row 2 minus row 1. And get the following result. I'm going to write above this one. No, I'm going to write it. Actually, I'm going to write it like this, just so it matches up perfectly. So in purple there I wrote row 2 equals 15 row 2's minus 8 row 1's. Do you see that that's basically what we've done here in 2 steps? First we multiplied row 2 by 15, and then we multiplied row 1 by 8. Which is multiplying row 2 by 15, row 1 by row 8, and then we did row 2 minus row 1. After we did that, which is the same as doing 15 row 2's minus 8 row 1's. The problem with the purple, can you see your brain making tons of mental math mistakes, trying to do all of those numbers in your head at once? 15 times 16 minus 8, no, 15 times 15 minus 8 times 2. Have that in your head and come up with negative 241. Even if you had a calculator, you might type in something wrong. So sometimes these preliminary steps, which are sort of a setup step, I'm just trying to get these numbers the same. Then I can subtract them, makes my mental math a little bit easy. Now definitely we're going to multiply by 1 over negative 241 to get that 1. And we've got y equals 1 nicely right away. Now I can take row 1 and minus 16 row 2's. Divide by 120, multiply by 1/20th. Now, I would argue that for a 2x2 system of equation, your previous techniques, elimination and substitution, are probably more efficient than this. And you're probably quite good at them. Even Gaussian elimination is probably more efficient than this. However, as soon as we go to the 3x3, I find that the Gaussian-Jordan elimination is more efficient and nicer to work with than our old techniques. So it's kind of interesting because, like, when you do it here, you're like, why would anybody ever want to do this? Isn't substitution and elimination more than sufficient? Gets me my answer just as quick, if not quicker? I would probably agree. But once we go to the 3x3, then still, obviously you see on the page here, we're going to do a fair bit of work. This is our goal. Our goal is to get this, and I'll color code it again. That's our first job, to get ones there. This is our second job. To get zeros there. Second job to get a 0 there. Anytime you can get ones along the diagonal, if you can do that early, go for it. Our third job is exactly the opposite, moving upwards. And our fourth job is that 0. So I'm going to set up my matrix, and what I did right away is this one has a 1. So I just switched row 1 and row 3 when I wrote it out. I kind of liked that 1 in the top left-hand corner right away. Not necessary. Okay? That's a personal preference. If you would have started exactly with 4115 and written it out in the order they have it there, it will work exactly the same. So I look at my main matrix. In the green, I want to get those zeros first. So can you see that you'll want to change row 2 to something, and you'll want to change row 3 to something? I'm just going to drag, maybe not, maybe. Oh, why is there a blue line there? There, I'm going to drag that down first. First, I'm going to just think about row 2. Can you see that if you took row 2 and subtracted 2 row 1s, you would get a 0? 2 minus 2 would give you 0. And then row 3, if I took row 3 and minus 4 row 1s, it would also give me a 0. Someone else then looks and says, Could I do row 3 minus 2 row 2s to get a 0? Yes. That also gives you a 0. So there are more than one way to get that 0. And both are right. Okay? What can you not do? You cannot go, I'm just going to take row 3 and minus itself. If you use the same row in your operations, you're just going to get, it's going to go away, right? The whole row minus the whole row itself will just end up with zeros. And then you'll have mistakes. So you do have to use different rows when you're doing stuff. But there are more than one ways, and I successfully keep row 1 the same. First I did the row 2, so I went row 2 minus 2 row 1s, 0, 3, 4, and 6, and 0, 9, 5, and negative 3. Now, one little mental mistake in here, and everything from now on will go terribly. Okay, so this is where, there's my answers. I can do a quick check, right? I'm going to circle this one here in red. 3, 4, 6. Is it correct? If it's correct, then 3 times negative 2, because y is supposed to be negative 2, plus 4 times 3, because z is 3, is supposed to equal 6. Double check it. Is that row correct? Yes. Now you're not going to double check every row as you're going along. But if you get the wrong answer in the end, and you're like, oh, should I start over from the beginning? Or where do I need to start over? Then you might want to check a little bit to see if you can find your mistake. But that is a way that you can see what's working. Oh, I might have erased too much. Oh well. And what's not. So next, get rid of that red, maybe. There, I got it. Undo. Yes. Next, 2. We want to get that 9 to be a 0. And here we have to be careful. Okay? This one isn't tempting, but sometimes you will get matrices that are tempting. I will show you a very tempting matrix temporarily. I'm going to just say, let's pretend this wasn't a minus 2. Let's pretend right here it was a minus 9. Oh, 9 and minus 9 makes 0. Very tempting. Can you see that as being tempting? If you're tempted by that, things will go bad. For this blue number 2, you cannot use row 1. Because if you use row 3 plus row 1 in any way, do you see that this 0 plus 1 will change our original green 0 back to a 1? And then we'd have to go back to step 1 and be like, oh, step 1, you have to get those zeros. And you start looping. We have to use row 2 and row 3 here to get step 2's blue 0. Because this 0 and this 0 will stay zeros when you add them together. Does that make sense? That's an important idea. And I said, if that was a minus 9, you'd be super tempted to use row 1 to make the 0. But then you accidentally make one of your previous zeros back into a 1. Okay, so I'm going to go back because that is not a minus 9. I'm going to stroke that out. So now, to get that blue step 2, that 0, I have to use row 3 and row 2. And in this case, it looks like I can just go 9 minus 3 times 3. That makes sense. I set that up. And I've got my bottom corners to be zeros. Divide by -7, multiply by 1/7. And I already know that z is 3, which matches up with my answer at the bottom, so I am happy. Now the purple stack. Now we got the bottom corner to be all zeros. We want to do the same process and get the top right-hand corner all zeros. So just like we got those two green zeros first, now we want to get those two purple zeros next. And we can do that all in one step. I'm gonna try to drag this down. There it is. Can you see that I can make the 4 into a 0 by doing row 2 minus 4 row 3s? Okay. And you'll also, it will be pretty obvious you want to do this. But in step 3, we will be using row 3 a lot to get those zeros. Because row 3 is really nice. It's got a 1 there and it's got zeros everywhere else. But again, if you choose other rows that get rid of your previous zeros, you're going to have to undo that step. And then row 1, I can just add that to row 3. And I get my zeros. Right, those are my purple zeros. Circle them here. That was my goal. To get those to be zeros. At this point, I can change that middle 3 into a 1 by dividing by 3 or multiplying by 1/3. I did erase part of that 3. And that matches up with what we know the final answer is supposed to be, so I'm very happy. Now finally, the last step, I want to make that one into a 0. You're going to have to use row 2, which is kind of obvious. You can't use row 3 at all. I'll change row 1 to be row 1 plus 2 row 2s. And we get our reduced row echelon form. So it's very systematic, right? I've color-coded it there, what you need to do first, second, third, fourth. If you do get zeros in any other order, you might run into a looping problem where like, oh, I got to go back and change this again. And then I have to go back and change this again. Especially in, right, I'll highlight, especially in this step, highlight it in blue actually. That step there, to get that blue 0, you could not use row 1. Even if you were tempted to want to use row 1. After step 1 and you got those 2 zeros, it's kind of like elimination. You got rid of the x's to get 2 new equations with just y and z. And now you have to use those 2 new equations to eliminate again. So it's the same process as we did in the elimination technique when you had a 3x3. But sometimes you forget that and you might want to be tempted to use row 1. Just be careful. Because if you undo one of those zeros that we got in the green there in our first step, then you have to go back to the beginning again and start over. Okay, so there are 3x3s there for you to try. Try that next one. Again, however far you got, try to see if you can finish it on your own. So I set up my matrices. I took the time to put the second one first because I like that one in the top right hand corner, top left hand corner. There we go. Next, I changed row 2 and row 3 to get those zeros. Step 1 got those zeros. I don't like these 16s and these 12s. Those aren't great numbers, okay? So I'm going to do a preliminary step when they're not nice numbers and just try to make them the same. So I change them both to 48s by finding a common multiple. And then I could subtract them to get that 0. I took row 3 and divided it back by negative 17 to get that to be a 1. And another thing I did, and I'll just write it on here. You see how I had taken row 2 and multiplied it by 3? I can undo that and change it back to the row 2 it was before. So I just rewrote the 16, the 7, and the negative 37 instead of having big numbers like 48, 21, and negative 111. Next I'm going to get row 2 to be 0. I probably could have also done this step all at once and got that to be 0, but I got excited.